All right, so this time we're going to look at how to how to simplify, a radical when there's variables involved, which is really not much more of an extension of just simplifying when there's numbers involved. All right, but let's take a look at a couple examples here. So this first guy, okay, first of all, the thing you should know about this is that this is by definition a square root. If there's no index number, that is an indicator that you are looking at a default number of 2. Okay, so if there's no number written there, you assume that it's a 2. It's kind of like how, like when we have expressions like 3x and 5x, right? If it's just an x, we just assume that there's only one x there, right? There's a default 1 that's assumed to be there. And similarly with exponents, if there's no exponent there, you assume that it's a 1 as an exponent. Well, with roots, if there's a number there, then great. But if there's no number there, it's assumed to be a 2. Okay. And the reason why is just that if you think about assume if it was a 1, that doesn't make sense, right? Because you'd be asking yourself what number times itself once equals the number in here, and it would be stupid, right? Because what number times itself once equals 5, right? 5. So why would we bother? Okay, so we don't really have a 1 that we'd ever use there. So 2 is the next smallest one, so that's the default one. So this is by default a power of 2, or a root of 2, excuse me. So when we go to simplify this, right, think about what's going on here. If we think about this in terms of like our birthday caking, right? So if I sort of break this down, the 9 is 3 times 3, and then I've got 4 x's, and then I've got 10 y's, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I've got 6 z's. Okay, so I'm looking for pairs, right? So here's a pair, here's a pair, here's a pair, 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 right? So when I go to simplify this, I know I'm going to have a 3 on the outside from that pair. I'm going to have 2 x's on the outside because I have 2 pairs of x's, right? So that's going to be an x squared. I have 1, 2, 3, 4, 5 pairs of y's. So that's y to the 5th. And then I have 3 pairs of z's. So that's z to the 3rd. Okay. And when you kind of look at that, when we see sort of what happened here and we compare that here, you can see that there's a connection, right? If we're looking for pairs, I'm looking for how many groups of 2 are there in this x to the 4th. Well, there's 2 groups of 2. How many groups of 2 are there in x to the 10th? Well, 5. X to the 6th, or z to the 6th, 3 groups. Okay, so you can sort of see where this comes from. So let's take a look at this guy, and we'll do it out the long way again. So 12, the prime factorization would be 2 times 2 times 3. Right, just a little birthday cake in my head. I've got 6 A's, and then I've got 4 B's, and then 1 C. Index number is invisible, ergo it's a 2, so I'm looking for pairs. So pair of 2's, got 3 pairs of A's, 2 pairs of B's, no pairs of C's. So on the outside, I'm going to have a 2 from this pair. There's 3 pairs of A's, so A to the 3rd. There's 2 pairs of B's, so B squared. And then left over on the inside, I have the 3 that wasn't part of a pair and a C that wasn't a part of a pair. Okay, so that's what this is going to simplify to. All right, so let's shortcut this a little bit. So looking at this guy, so 20, you can hopefully break this down into your head. That's 4 and 5, right? So the square root of 4 would be 2 on the outside. And I'm going to have a 5 left over on the inside. Okay, A to the 3rd, I'm going to have 1 pair of A's with 1 left over. B to the 6th, that's 3 pairs of B's. So B to the 3rd. C to the 7th, that's 3 pairs of C's plus 1 left over, right? So C to the 3rd and 1 left over. And that's it. Okay, this guy over here. So 45, that's 9 times 5. So 3 on the outside, 5 on the inside. A to the 7th, that's going to be 6 pairs with 1 left over. B to the 5th, that's 2 pairs with 1 left over. C to the 3rd, that's 1 pair with 1 left over. And there's my simplified radical. Okay, so that's no big deal. So now when we start upping this to another index number, Okay, the only thing that's going to change is kind of what sets you're looking for. So when I write this one out, so 16, I'm going to do this all out again. 16 is 4 2's multiplied together. Right, then I've got 5 A's, and then I've got 3 B's and 2 C's. And I'm looking for this time, right, I'm looking for sets of 3. So here's a set of 3. There's a set of 3. There's a set of 3, and that's it. So on the outside, I'm going to have 2AB because that's what I had for sets. And then left over on the inside, I'm going to have a 2 A's, so A squared, and 2 C's, so C squared. Okay, so it's very similar, except instead of saying, well, how many pairs are there, I'm looking for how many sets of 3 are there. Well, there's 3 A's here with 2 left over. There's 3 B's there. There's there's no sets of C's there, so those just stay inside. Okay, this guy over here, we're looking for sets of 4. So with my 12, 12 is 2 times 2 times 3. I've got 5 X's. I've got 10 Y's. And then 8 Z's. Okay, so again, I'm looking now for sets of 4. So here's a set of 4. Here's a set of 4. Here's a set of 4. 4, 4. Right? So on the outside, I'm going to have an X, 2 Y's, 2 Z's. And on the inside, left over, these guys, there's no sets there, so I'm just going to multiply those back together to 12. I have 1 leftover X and 2 leftover Y's. Okay, and again, you can kind of just look at this and figure out, okay, well, how many sets of 4 are there? Well, there's 1 set of 4 with 1 left over. There's 2 sets of 4 with 2 left over. There's 2 sets of 4 with 0 left over. All right, and then these last two, so these ones are going to end up being multiplied together. Okay, and there's sort of 2 different approaches that you can take when you're doing this. You could, right, simplify each one separately and then multiply them together. But the easier thing to do is just look at them as sets. Okay, so if I put the 4 and the 12, 4 is 2 times 2, and then 12 is 2 times 2 times 3. So there's all my numbers broken down. I've got 2 X's in this one and 2 X's in that one. I've got 2 Y's in this one and then 5 Y's in that one. So there's everything all together, and I'm looking for sets of 3. So here's a set of 3. There's a set of 3, set of 3, set of 3. So on the outside, I'll have a 2, an X, and 2 Y's. And then on the inside left over, I'm going to have 2 times 3 is 6, and there's 1 X and 1 Y left over. And that's it. All right, and then the last one, I'm going to do the same thing. Okay, so, ooh, look, a negative. I know I'm going to end up pulling that out to the front. Deal with that in a second. So 8 is 2 times 2 times 2. 4 is just 2 2's. 5 A's here with 3 more there. Right, 2 B's here with 4 more there. And then there's a total of 8 C's, right? And we're looking for sets of 5. So here's a set of 5. 3, 4, 5. There's a set of 5. Here's a set of 5. There's a set of 5. Right? So I'm going to have a 2 on the outside. I'm going to have an A on the outside. I'm going to have a B on the outside, a C on the outside for my sets. Right? I have 3 leftover A's. I have 1 leftover B. And I have 3 leftover C's. And don't forget about that negative right in the front. Okay, so that's how you're going to simplify these. And you can probably come up with some pretty decent shortcuts to do this in your head, right? You can kind of look at these and just collect how many you have. So like I look at this and say, oh, look, there's a total of 8 A's. So how many sets of 5? Oh, 1 set of 5 and all 3 left over. Okay, so they're not too bad to do out in your head. You do not have to write all this out when you're simplifying them. That can just kind of help as you're starting to like wrap your head around what exactly is going on here. Okay, so simplifying with variables, not too big of a deal. Once you sort of understand the concept behind it, it's not horrible.